Hi everyone, this is working through my predicted paper 2 for the Eduqas GCSE Maths Foundation tier and on the calculator paper. Just a reminder, this is only a predicted paper based on past topics, question styles and patterns that have appeared regularly in previous Eduqas exams. There is no guarantee that these questions or topics will definitely come up. So grab a pen and calculator and have them at the ready. Pause the video, have a go at the questions before I go through them. Let's start at question 1. Right, so a florist creates custom bouquets using the menu below. And it shows a flower menu with roses, tulips and daisies, all for various prices, £2.50, £1.80 and £1.20. Amelia wants to make a bouquet with 6 roses, 5 tulips and 4 daisies. Work out the total cost of the bouquet. Okay, so we're going to put all of this into our calculator, so we don't need to do as much maths as we were before. So we have 6 roses, and the roses are £2.50 each, so £6, £2.50, 6 times £2.50. And we have 5 tulips, we've got 5 times £1.80. And we have 4 daisies, which is 4 times £1.20. And we're going to use a calculator to calculate those prices. Once you've put them into your calculator, and I'm trying to get the closest example to a Casio calculator and put each one of these in the bracket so it can calculate. Make sure at the end, if it comes up as a fraction, there's the button S to D, which is standard to decimal. So we want it as a decimal form, which will give us our 28.8 and the final cost, which will be £28.80. Make sure you put the 80 pence to let us know that it's 80 and not 0.8. We need to start when we're doing a correct money form, we will need to do the 28.80. The florist has an offer. Spend over £25 and get 12% off your total. Does Amelia qualify for the discount? If she does qualify, work out the final price she pays. So I have my total amount here, and this is bigger than £25. So way to write it. It's bigger than £25. Therefore, yes, she gets the discount. So I would need to work out 12% in order to take that off my total. So I'm going to type into my calculator 0.12. However, if you can use 12% on your calculator button, but that will give you your 0.12 anyway. So 0.12 of my £28.80. Always remembering that in our maths calculator paper, of equals time. So that's going to equal 3.456. But as you know, we don't have 456 pennies, so we will need to round it. So I'm going to cut that off out my 2 decimals because it's only as soon as it goes up an extra to the next 100, it's going to be an extra £1. So we haven't got as 1,000th in pennies. So we're going to round it. 6 is higher than 5, so it gets rounded up to, sorry, that's my pound sign, £3.46. I have that off my total, so I've got that 12% off my total. So I now need to, again, just type it into your calculator. Getting used to using our calculator now because now we're on the non-calculator paper. And just typing that into my calculator will get me £25 and 34 pence. Making sure we're using the correct money format there. And moving on to part C, Amelia pays with two £20 notes. So two £20 notes, 2 times 20 is going to give me £40. How much change should she receive? So I type in straight into my calculator, £40 minus my 25.34. And I get £14.66. A florist has a spinner to randomly choose a free flower to add to a bouquet. The spinner has 10 equal sections. Write down the probability of landing on each flower. So because there's 10 possibilities, 10 equal sections, 10 possibilities. All I need to do is count how many options there are for rows. So there are 4 options for rows, so that will be 4 out of a total possible 10. And then the tulip, we have 1, 2, 3, so that will be 3 out of my total possible 10. And daisy, we have 2 out of my total possible 10. And sunflower, 1 out of my total possible 10. So they are my 4 probabilities. I could simplify. With probability, you don't usually need to, and it doesn't usually say simplify, but that would be right still if you did 2 over 5. We can't simplify 3 over 10. We can simplify 2 over 10 to 1 over 5, and we can't simplify 1 over 10. But you can just leave your answers like this. Mark the probability of landing on a daisy on the probability scale below. So the Eduqas likes probability scales. They come up fairly often, and it shows an impossible, or we could have a certain event. So that means one of those things definitely will happen. So if I was to spin it, I'm either going to get a rose, a tulip, a daisy, or a sunflower. I'm going to get one of them. So it's certain I'm going to get one of them. However, it's impossible that I'm going to get a daffodil, because a daffodil isn't on the spinner. So it's asked us the probability of a daisy, and we have 2 daisies, and a probability scale usually has an equal amount depending on our possibilities. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 possibilities. So our probability scale usually shows 10, or sometimes maybe half of them or a factor of that amount. But we only need to show daisy, which is here, which is because there's 2 daisies, so that will be 2 of our increments. Okay, on to question 3. A flight from London to Barcelona is planned as follows. The scheduled departure time is 14:35, that's 2:35 p.m, and the flight duration is 2 hours and 25 minutes. However, the flight is delayed by 35 minutes. Work out the arrival time in London time. So the London time is given as by the departure time. So we need to work out that time. So because the flight is delayed by 35 minutes, the first thing I'm going to do is work out the new departure time. I'm going to go in steps, so I'm going to add plus 25 minutes. So if I add 25, that's going to get me to 3 o'clock. I then, 25 add 10 minutes is going to be my total 35 minutes. So if I add another 10 minutes, that's going to give me a departure time of 3:10 or 15:10. So my new departure time is going to be 3:10. New departure time 3:10. My flight is 2 hours and 25 minutes. So I personally like to do my minutes first. So I'm going to add my 25 minutes. So this is going to be my 25 minutes added on. So 10 plus my 25 is going to be 15:35. I can then add my 2 hours. So to go in steps and stages, I can then add my 2 hours on. So the total 2 hours and my 25 minutes is going to be 17:35. So going in stages, I worked out my new departure time to be 15:10 or 3:10 p.m. and then added my 25 minutes, added my 2 hours. So the arrival time, London time, would be 17:35. However, the next part of the question says, but Barcelona is 1 hour ahead of London. So there's a time difference between London and Barcelona. So if Barcelona is an hour ahead, it's an hour forward. So instead of it being 17:35, it's an hour, 1 additional hour ahead. So adding an hour on would mean the local time in Barcelona would be 18:35. Okay, on to part C and the last question for working with time. So Leighton, he's a passenger, must check in 1 hour and 45 minutes before the new departure time. So he's going before the new departure time, which we've calculated to be 15:10. So that's the departure time. He's got to check in 1 hour and 45 minutes before. So we're working backwards. So again, I'm going to do my minutes, and I could do it in stages. So I'm going to subtract 45 minutes. So going back to 3 o'clock would be 35 minutes left remaining, going around my clock. So imagine I've got my clock here. My minute hand is currently here, taking me back to 10 minutes. And then 30 minutes would be 40 plus, and then subtract an additional 5, which would take me around here on my clock, if you can visualize. It would take me to around here on the clock, which would be my 25 minutes. So my 25 past the previous hour. So that's going to be 14:25. So subtracting 45 minutes, going backwards from my clock, is going to take me to 14:25. And then I've still got to go another hour backwards. So going another hour and going in steps, it makes it a lot easier. That's going to take me to 13:25. Sorry, I've gone across the marks there. So he needs to arrive at the airport at 13:25 or 1:25 p.m. I'm sorry I haven't drawn the whole clock out, but it does sometimes help to visualise or jump in stages going backwards. Amaya goes to Ibiza. She needs to exchange money. When she exchanges the money, the exchange shop charges a 3% commission fee from the pounds before the conversion. So before it's converted, they take 3%. The exchange rate is £1 equals €1 20 cents. Amaya exchanges £150 into euros. Work out how many euros Amaya receives. So the first thing I'm going to need to do is work out my 3% of 150. So as you can see, I'm using my calculator to the side. I'm putting in my calculator 0.03 times 150, and that's going to give me my £4.50. Another method on the calculator is to literally use the shift button and write 3%. Again, remembering of equals times. And then I can work out my amount I'm converting. So 150 minus my £4.50 because the commission taken off. So I'm going to be converting £145.50. Okay, now I just need to do my conversion. So I'm converting this amount using this exchange rate. So because I'm going from pounds to euros, I will need to multiply. If I was going the other way around, I would need to divide. So £145.50 multiplied, so multiply that by my conversion rate, which is 120, which is going to give 174 euros and 60 cents. The last thing I'm going to do is just make sure that I've written it in correct money format with my euro symbol. And that's that question complete. And on to part B. And it says Amaya spends 36 euros on food, 18.50 on transport, £42.30 on activities. Work out how much money she has left in euros. So a nice simple subtraction one for us. And again, smarter not harder. Please make sure you're using the calculator for these questions. Minus my 36, minus my 18.50, minus my 42.30. And that will give us an answer of 77 euros. I'll make sure I use my euro symbol. 77 euros and 80 cents, but making sure you're using the calculator to do that sum. Okay, so we have the next question. Before returning home, Amaya exchanges her remaining euros back into pounds. But this time the exchange rate is €1 equals £0 and 80 pence. The shop charges a 2% fee on the amount of in pounds after the conversion. Using your answer from part B, which is our 77 euros 80 cents, work out how much money Amaya receives in pounds after the 2% fee is taken. So the first thing I'm going to do is convert it. Again, because I'm going from euros to pounds and that is our conversion rate, I only need to multiply. I don't need to divide in this case. If I had have been given the conversion rate just from pounds to euros, I would have had to divide to go back that way. But however, luckily, I only have to times by my 0.8. So I put into my calculator this amount times 0.80 and I get £62 and 24 pence. I then need to take my 2% fee. So I'll now need to calculate my 2% fee. So again, putting in my calculator, remember, of equals times. So putting this again into my calculator to get my £62.24 times, so I want 2% of this. So putting that into my calculator. And that gets me £1 and 2.48. Problem is with this question is we only have 100 pennies in a pound, so we will need to round this number. So they do need to do some rounding. So it will be £1 and 24 pence because the cut-off after that, the 4 is smaller than 5, so it will be £1 and 24 pence. So my total amount will be that she will receive back, Amaya will receive back, is my £62.24 minus the commission charge, which is £1.24, which will get me £61 back exactly. Question 5. A site manager records the number of bricks used by a construction team over a week. And we're asked to draw a bar chart to represent this information. To show you physically drawing a bar chart, that's going to waste too much time in the video, so I'm going to go straight into showing you a drawing of my bar chart. Okay, so a number of key things to look out when drawing a bar chart. Make sure your scale, for your number scale, make sure that's as even as you can. Here I've gone up in tens and each block of 10 blocks represents 20. So it's an even scale on the side. Also make sure you always label your axes. So always make sure you label your axes. So I've got number of bricks for my y-axis And for my x-axis, I'm clear that I've labelled the days of the week. And also make sure you have a title. So I always, if you're going to draw a pie chart or any type of a chart or graph, make sure that if somebody was just looking at it without the information, they could see what it was kind of representing. So it's got a title, it's got the axes labelled. So always think to yourself, would I be able to read this graph without having any information? Would I know what it was about? And also please make sure you have an even scale axes when you draw your bar chart. Question 6. A packet of biscuits is shared between Bradley and Troy in the ratio Bradley to Troy 2 to 3. Write Troy's share as a fraction of the whole packet. And what I've done here is I've drawn the boxes. So Bradley has 2 parts and Troy has 3 parts. The thing is with ratio is even though it's an unfair sharing, Troy has more than Bradley, there's still an equal amount in each of these parts, and that's where sometimes the division can get confused. So I always find if you struggle with ratio, definitely draw the parts or find a method that suits you to the way you can see that it's an equal share. So write Troy's share as a fraction of the whole packet. So Troy has 3 parts and the total, there's 5 parts in total. So in total, 3 over 5, because that's the total amount. A common mistake there would be to write the number 2 because Bradley's got 2 parts, but in total it's 3 of the 5 and in total that's the fraction. And the next part, there are 20 biscuits in the packet. How many biscuits does Bradley get? So there's 20 biscuits in total. And there's 5 parts in total. And as I said, an unfair sharing, but there's still an equal amount in each of the parts. So 20 divided by the 5 parts in total is 4. So that means there's 4 in each of the parts. So Bradley's going to get 4, add 4, 12 parts. 2 times 4, which equals 8. So Bradley gets 8 biscuits. And Troy would get 12, but we haven't been asked that. Okay, question 7. Write 17 as a fraction of 12 and put your answer as a mixed fraction. So here we have 17 as a fraction of 12, and it would be simple. People always think that the smaller number has to go on the top, but as is 17 as a fraction of 12, it means 12 is going to be our denominator. So if I was like 3 as a fraction of 4, it's saying 3 out of my 4 parts. That's saying 17 out of my 12 parts. And I want that as a mixed number. So every time I have 12, so when I have 12 over 12, it's like 12 slices of a 12 slice pizza, I'm going to have a whole number. So 12 goes in 17 once, so that's one whole number. And I have 13, 14, 15, 16, 17. So I have 5 12ths left over. Part B, work out 1.03 times 2.35 all over the number 5 and write your answer to 2 decimal places. So here we're just going to need to calculate this into our calculator. We're going to put it straight into our calculator. Don't try and work this out in your head. Don't work smart, not harder. Calculator paper, we're using a calculator. If you didn't have like a Casio calculator and you can't use the fraction button, you would need to work out the top number first and then divide it by 5. But we're using our Casio, so we just put it exactly like that into our calculator. A length is measured as 10 centimetres. Correct to the nearest centimetre. Write down the smallest possible value. So if something has been measured to the nearest centimetre. That means it could have been a decimal. So thinking about the numbers it could have been, so 10.2 would be rounded to 10 to the nearest centimetre, wouldn't it? Because we could cut our line off here. It's smaller than 5, so we round it to 10. Going the other way, 9.7, that would be rounded to 10 centimetres because our tenth is bigger than 5, so we round it to 10. So we round it to the nearest centimetre, the nearest whole number. So when we're thinking of rounding, whereas if I picked 10.5, because that's a 5, I would actually round this up to 11 centimetres. So I'd round this up to 11 centimetres, so it can't be that one. But we want the smallest one possible. So we're looking at one of the numbers in our 9s, and the smallest value possible would be 9.5. Anything smaller than that, 9.4999 or anything like that, would be rounded to 9. So that would be our smallest possible value. On a construction site, 2 machines are used. A cement mixer completes a cycle every 12 minutes and a conveyor belt completes a cycle every 18 minutes. Both machines start their cycle at the same time. After how many minutes will the 2 machines next finish the cycle at the same time? So with this, you have to presume that there's no in-between times. So there's no loading in between. So they would continue straight away. So the first cement mixer would go 12 minutes and then it would stop again at 24, complete another load at 36, and then another load at 48. We're adding 12 on each time. So essentially we're doing multiples of 12. And that would continue on. And then we've got 18, 36, and adding 8 onto here would give me 44 plus another 10, so that would give me 54. But as you can see, I have a common multiple here, and that's my lowest common multiple. So after 36 minutes, they will finish a cycle at the same time, after 36 minutes. And part B, how many cycles will each machine have completed by this time? So the cement mixer has gone 1, 2, 3 cycles. Cement mixer, 3 cycles. I mean, you don't necessarily need to write it all out as long as you can see 3 cycles for cement mixer and 2 cycles. So 2 cycles for the belt. Belt, 2 cycles. The site manager wants both machines to finish together exactly 4 times during the day. Write the total time that the machines are running. So if every 36 minutes they both stop in time, so every 36 minutes the cement mixer would have done 3, the belt 2, but in total that's going to need to happen 4 times. So you've got 36 times 4. And again, put that straight into your calculator, and that's going to give you 144 minutes. Which you'd think, okay, 3 marks, 144 minutes, but it says write your answers in hours only. So 60 minutes per hour, so 60 plus 60 is 120, so that's 2 total hours. So we have 2 total hours, which is 60 times 60, 60 plus 60 equals 120, so that's the 2 hours. So there's an additional 24 minutes. We're not going to put it, because it says hours only, we need that as a decimal of an hour. So here we want to turn that 24 minutes into a decimal. So if I write that as a fraction, because that's 24 minutes of an hour. So 24 out of the 60 minutes, that would be as a decimal, as a fraction first, and then we can turn it into decimal as we've done on our calculator to get 0.4. So the total time would be 4 hours. And a lot decimal time trips a lot of people up, because you'd expect a lot of people think, oh, 2 hours and 4 minutes or 2 hours and 40 minutes, whereas actually 24 minutes, and it's actually 0.4 of 60 minutes. So 2.4 hours is our answer there. On a construction plan, a triangular section of flooring is marked on a coordinate grid. The coordinates of two vertices are 2, 4, so the coordinates 2, 4, and B, 10, 8. Find the coordinates of the midpoint of the line AB. So you could draw the line in and see whereabouts the middle would be. However, I'm going to look at it in a different way. So I've got the number 2 here along my x-coordinate and 10. So the middle, so that's 8. So the difference between 10 and 2 is 8. Half of 8 is 4. So if I move 4 along here, that's going to take me to 6. So my x-coordinate here is going to be 6. And looking for my y-coordinate, the difference is 4 and 8. So 8 subtract 4, so the difference here is 4. 1, 2, 3, 4. Half of 4 is 2. So it's going to be 6. So my y-coordinate there is going to be 6 as well. So going along the corridor and up the stairs to 6, 6. My midpoint is going to be there. And as I said, you could just draw a line across there, and it's but it's best to just double check. Draw a line and see visually where the midpoint is. A lot of you will be able to spot it straight away, but that's how we work it out. A third point is given as C, and the coordinates are 6, 2. Draw the point C on the grid. So just making sure we can follow the rule. Along the corridor of the stairs, x coordinate always goes first. So the coordinate is going to be here. And I am going to label it to make sure I get the points. These probably should have been labelled as well. Okay, another point lies. And it says draw the triangle ABC. So we've hopefully got our mark for drawing the point, and now we need to draw the triangle ABC. I would very much recommend using a ruler to draw any shapes like this, because if you were asked to identify the shape afterwards or anything like that, identify what the shape looked like, if I was asked to identify anything like that, so you could be able to more likely to be able to see what type of shape it was. So if it was an isosceles triangle or right angle triangle, you're more likely to be able to identify what shape it is. So sometimes they do ask to identify the shape, which could be some kind of quadrilateral or something like that. So if you use a ruler, you're more likely to be able to see what shape it is. And that's my triangle drawn there. Okay, I put my ruler to the side for a moment. Another point D lies within the triangle, so it lies somewhere in this triangle, but it is also on the line y equals x. What is a possible coordinate for D? So we need to think about the line y equals x in order to do this question, and it's just a bit of an extra learning for us of the things that might come up. On the line y equals x, that means x and y are always going to be the same. So it doesn't matter what they are always going to be the same. For example, if x was equal to 1, then y would also be 1. So because x equals y. If x was equal to 2, y would also equal 2. If x was equal to 10, y would also equal 10. So when we're asked to draw lines, we need to think about what that actually means. Sometimes you might get different types of line y equals 3, where the y coordinate always equals 3, but x is always changing. But in this line, y and x are always the same. So if we think about what that looks like on a coordinate grid, we have 1, 1, 2, 2. And we've drawn 10, 10. And we would have 4, 4. We would have 5, 5. So y and x are always the same. So that line is going to go straight through my coordinate grid there. So just drawing the line on and moving our ruler through those points that we have drawn as well. That is what my line would look like. So some of my coordinate points, so I would have, so 4, 4, also it's within my triangle, but it also lies on that line, or 5, 5. So any of those ones. So I'm going to get rid of these answers, because these answers, the problem is with these, they're on my line, but they're not lying within my triangle. So the points that lie on my line but are also within my triangle are this point here. We've got 4, 4. So that would have been an okay answer. That will get me the marks. Or 5, 5. So just a little one to help us thinking about what it means for what the equation of a line looks like. And moving on to question 10, and we have a construction apprentice. It's sorting different floor tile designs based on their shapes. Below is a list of shapes used on site, and we have some information about shapes A to E. And it's asked us to name each shape A to E. So we need to go through and look at the details we've been given for each of the shapes. So here we have 4 equal sides, so all sides are equal length, and they're all 4 right angles. So that is going to be a square. So we have 4 right angles, 4 equal sides. That is going to be our square. If it could have been a different shape if it was like a bit wonky to the side and I didn't have the right angles, but it's definitely going to be a square. And for the next one, we have shape B. A shape with 3 sides. 3 sides is going to be a triangle. We know it's going to be a triangle straight away, but it also gives us that 2 sides are equal. And drawing it over here. If 2 sides are equal, we usually identify the equal sides by have 2 lines. And that's going to be a isosceles triangle. You will always get tested. It's rare that I've seen a paper where you haven't been tested on your knowledge of the isosceles triangles or a equilateral triangle. And for shape C, I have a shape with one pair of parallel sides only. And there could actually be multiple shapes because it hasn't said how many sides it has. As long as these lines are parallel, mine are not parallel. That's me trying to draw. I should have used a ruler. I mean, they could go in there and make it a 6-sided shape, but just so I can name the shape easily, I'm going to make my shape look like this, because as long as those 2 lines there are parallel, these 2 lines are not parallel, that's a possibility for my shape, and it's going to be a trapezium. And then moving on to shape D, we have a shape with 4 sides where opposite sides are equal and parallel. So this time, it's 4 sides, but opposite sides, the same way we did with our trapezium. They're going to be equal length, but those 2 lines are parallel. But these 2 lines on the other side also need to be parallel now. We usually draw our parallel arrows to let us know they're parallel. And that's going to be a parallelogram. Hopefully I don't spell it wrong. Parallelogram. And shape E, a shape where all points are the same distance from the centre. Tricky one if you were just thinking about this one. But I mean, to keep something all the way the same distance all the way around, it's going to have to be a circle. Apparently it's impossible to draw a perfect circle freehand, and mine is far from a perfect circle, but as long as we get the name written right in here. And they are our 5 shapes. I would say it's easy to forget the properties of 2D shapes, 2D polygons. So I would definitely think revising these in the weeks coming up to the exams to try not to forget, just revising what 2D shapes there are, names of shapes. I would really recommend revising those hexagon, pentagon, and just making sure you understand like how many sides each shape has, and also lines of symmetry, stuff like that, that it's important to revise before the exam. On to part B, and we have shade 5 boxes, so the pattern below has just 2 lines of symmetry. And a lot of my learners seem to forget what a line of symmetry actually means. So I included my first learning of what I remember back in primary school learning about lines of symmetry as a butterfly. A line of symmetry is just what looks exactly the same on the other side. So if I put a line here as if it was a mirror line, that would be mirrored exactly the same on the other side. So a line of symmetry just means where can I put a line where it looks exactly the same on the other side. So as you can see here at the moment, if I was to put a line of symmetry down here, there isn't a box here that looks the same. If I was to put a line of symmetry here, there's a box there, but not a box there. So it cannot be a line of symmetry. So we need to add those boxes so that it has 2 lines of symmetry exactly. So I'm going to go through on my shape. So I need to shade 5 boxes so that the pattern has just 2 lines of symmetry. So if I'm going to imagine, or I'm going to put it, I'm not going to imagine, I'm going to put it down, a line down the middle of my shape. Sorry, it's not raining. And going step by step through each row, I've got 2 boxes here, 2 boxes here. That row has a line of symmetry. But I've got a box there, however, I haven't got a box here to make that be a line of symmetry, so I can shade that shape. Going on to my 3rd row, I have a box here, however, I need a box on this side to make that a line of symmetry. So far I've done 2 boxes. And my 4th row, I have a box there, but I need a box here. So I've managed to do 3. So now, with this is actually a line of symmetry. This is okay, this 5th row, and the last row, that's okay. I'm going to potentially put another line of symmetry here. And go for my middle one and see if I can add some boxes there. So now I'm looking at these ones. So going on my different columns. So this one has 2 on, and if I was to flip it on the other side, this also has 2. However, there's a box here. There isn't a box here. So now I've added that box. That column has one line of symmetry based from this line. This one's okay because outside of my line I have a box there and a box there. However, on my 5th column, I've got a box at the top, but not a box below. But my 6th column is fine. I have 2 boxes equal distance apart and 2 boxes equal distance apart. So I've now shaded all of my 5 boxes and made sure there's 2 lines of symmetry. If I was to put a line across here, they're not going to be the same. It's not going to be the same on the other side because there's not exactly 2 boxes, not a box there and a box there. It's not quite going to be 2 lines of symmetry. So they are my 2 lines of symmetry now. Shade 2 boxes in the pattern below so that it has rotational symmetry of order 2. So at the moment, if I was to turn this shape around, it doesn't matter how many times I turn it around, I could turn it 90 degrees, that's not going to look the same as it does here. If I turned it upside down, those 2 boxes would go here and there would be an empty box here, so it wouldn't look the same upside down. We need to shade 2 boxes so it has order of rotational symmetry too. So I'm going to shade this box here. And this box here. And then I'm going to show you what happens. So it looks like a number 2. 2 for 2. 2 lines of 2 rotational symmetry, and it's the number 2. So I'm going to show you what that looks like when I turn it around. Okay, I've changed the colour to a slightly more grey from the black so you can see it more realistically. And as you can see, if I turn that round, all the way around that way, it still looks the same. So that's can twist 180 degrees and then our 360 degrees. So it now has order, rotational symmetry too. One more time, 1 and 2. On to question 11. Simplify the following expressions. So here we have index rules. So question 11 is index rules, and if you're unsure about it, I highly recommend you revise it. So index rules. Oh, change the colour of the pen for the last question. I quite like it. Okay, so when we're multiplying, and I'll probably do, so this video isn't too long, I won't go into the index rules, I'll probably do a shorter video explaining each of these rules. However, when you're multiplying where the base is the same, so when you're multiplying and you have indices and the base is the same, we just need to add our indices. So here I've got x to the power 3 plus 2, and I will write this out, 3 plus 2, which is going to equal x to the power 5. A common mistake would be to multiply them then and put x to the power 6. But it is x to the power 5. And similarly, if we're doing the opposite way and the base is the same and it's a division, then I subtract the indices. So I've got 5 minus 3, which equals y to the power 2. And here we have a different rule, so we're multiplying it out from the brackets, and here I do need to multiply because essentially I have a to the power 2 times a to the power 2 times a to the power 2. So if I was to add them using this rule, I just multiply here. So I have a 2 times 3, which equals a to the power 6. So it's a lot of rules to remember, so I will do a video trying to help you with the understanding of it, because obviously if you rely on memory only, it does make it tricky. Anything to the power of 1 just equals itself, because you're just multiplying 5 on its own. It's just 1 5. Obviously 5 to the power 2 would be 5 times 5, but 5 to the power 1 is just 1 5 on its own. So that one is kept nice and simple. Just side note, anything to the power of 0 equals 1. So if I had 5 to the power 0, that would equal 1. Obviously, that's not the question that we've been asked, but it does, just a side note, anything to the power of 0 is equal to 1. So 100 to the power of 0, 1,235 to the power of 0 equals 1. Anything to the power of 0 equals 1. Let's chuck a little letter in there. X to the power of 0 equals 1. Just a side note. But 5 to the power of 1 just equals 5. On to question 12. A car dealership is offering 2 different finance options for the same car priced at £9,000. Simple interest is one option, is option A, and the annual interest rate, so yearly interest rate, is 5.5%. So we'll be adding on 5.5% every year, and the number of years is 4. So with simple interest, so we either get simple interest or compound interest, and the chances of getting at least one of them is extremely high in your exam. So with simple interest, we just need to calculate the interest and then multiply it by 4, because it just stays the same. Same amount is added on each year. So I'm going to do 0.0. Remember, it's not 0.55, because that would be 55%. So it's 0.055 of, remember on a calculator paper, of equals times, of £9,000. So putting that into my calculator, my 0.055 times 9,000, and that will give me £495. But I need to pay that for 4 years, so I'm going to multiply that into my calculator. But as you can see, I've just carried my answer straight over and done answer times 4, which equals £1,980. And if I add that to my original, because obviously I've still got to pay for the car, so that's £9,000. So add that to my original £9,000. And remember, I'm just putting all of this into my calculator. £1,980. Obviously, I've just carried over my answer. It's going to give me £10,980. So that's how much it's going to cost. I've got no arrangement fee. That's how much it's going to cost for option A. Moving on to the compound interest rate, option B. So this time it's 4% interest, number of years 4, and arrangement fee £300. I'm going to do something slightly different for this one. Instead of just working out my 4%, which would be 0.04, instead of doing that and then adding it on to the £9,000, I'm going to calculate it in one swoop and do my 1 times £9,000 and add my decimal on to my whole amount. So I'm adding the 0.4 onto the whole amount. So if I multiply that by £9,000, I will get, and I'll put that into my calculator here. So on my calculator, I put 9,000 times 1.04. And that gives me the answer, £9,360. Two ways I could do this now. I could keep doing that. So I could keep doing my 1.04 times this new amount and then find a new amount and do 1.04 again. However, I know that I'm going to have to multiply it by 1.04 4 times because it's 4 years. So I'm just going to do it to the power of 4 and then multiply that by my 9,000. Because if I do that, oh no, that's not 9,000, that's 900. So if I do that, put that into my calculator, so it's going to save me keep adding it on. However, compound interest is that's something you need to revise. Please revise that. So putting my new calculation into my calculator, so I've got 9,000 times 1.04 all to the power 4. That's going to give me £10,528, and it is going to give me 4 decimals, 5 decimal places, 4. Obviously, I know that pennies, we only have 100 pennies in a pound, so I'm going to need to round it to 2 decimal places. So it's going to give me a final answer of 10,528. And my 7 is higher than 5, so I'm going to round up to 73 pence. And now I just need to add my arrangement fee on. So add my arrangement fee onto here. So I'm going to plus my £300. Plus my £300 arrangement fee is going to give me £10,828.73. That means option A is cheaper. Option B is cheaper. And just want to write that out here. Option B is cheaper. And on to part B, and I'm really sorry, I've already done the paper, but thinking about this, you would normally get a really tricky one like this at the end. But is option B is always the cheaper deal because the interest rate is lower? Is this statement correct? Explain your answer. So it needs you to try at different amounts here. So if I'm going to try smaller amounts because of the added arrangement fee. I don't think if on a smaller amount, it would always option B would always be the best option. So if I do £1,000 and multiply that by my 0.055, I'm going to get £55. And all this, I'll show you all this on the calculator as well. And then times that by 4, which will give me £220. So the total for this one would be £220, and the total amount paid £1,220. Whereas if I was to calculate my interest with my 4% and my compound interest, calculating that with my compound interest, so using the same formula I did before, 1,000 times 1.04, so it's a 4% to the power 4. I'm going to using my calculator to the side, as you can see, I'm going to get £1,169, and rounding it, because I'm going to round it on my calculator to get 86 pence. I would then need to add my £300, which again I'm going to use my calculator to do. Add my £300, which is going to give me £1,469 and 86 pence. So option B, when it's a cheaper price, is not always cheaper. So option B has not always been the cheaper option. So I'm going to give no, and I've explained my answer by using an example. Okay, and on to question 13, and we have a flower shop sells bunches of flowers at different prices. The number of bunches sold at each price in one day is shown below. Estimate the mean price per bunch sold after removing the returned flowers. So these are the price sold. I think that's some extra information we don't need there. But if you need to revise this, you need to revise estimating the mean from a frequency table. When we calculate the mean, we add them all up and divide them by how many there are. The problem is with this situation is we don't actually know the price. So we could have had a bunch sold for 50p or £4.50, anything in between here. So in order to kind of calculate the mean, we're going to have to take an average of each category, so of each class. So we have the midpoint. So the midpoint of 0 and 5 is going to be £2.50 or 2.5. The midpoint of 5 and 10 is going to be 7.5. Probably should have drawn my table a bit neater. The midpoint of 10 and 15 is 12.5. And the midpoint of 15 and 20 is 17.5. And on average, if we were to add those up, I would have 2.5, add 2.5, add 2.5, add 2.5 4 times. But just to make it easier, I can just multiply each of these. So my midpoint times number sold, midpoint times the sold, is going to be 4 times 2.5, which is 10. And then I have my 7 times 7.5. Again, this is a calculator paper, so work smarter, not harder, and do these on the calculator. I have 52.5. My 5 times 12.5 is going to give me 62.5. And then I have my 2 times 17.5, which is going to give me 35. But I need the total of these. So the total, because I'm supposed to add them all up. So the total here, So that gives a total of £160. And as it's the mean, we need to average it out, so divide it by the number that there are. A common misconception or common error here would be to divide it by 4 because there's 4 columns. However, we need the total of pizza sold. So we need the total, flour sold. We're dividing it by this total here, which is 4 add 7, 11, add 5 is 16, add 2 is 18. So here I need to do 160 divided by 18. And again, it's a calculator paper, so make sure you're using your calculator. That gives me 8.88888888889. But I'm going to round this to 2 decimal places because we're talking about money here. So it's going to be £8.89. And then we have part B, and we have a fairly easy one. We have the shop owner claims the average price is closer to £8 than £9. Is she correct? Show your reasoning. Good little question like this helps us kind of show, it kind of gives us an example of if we're close or not, because if you'd have got something like £4, you'd kind of known to go back and check that answer there. And it's closer to £9, so no, she is closer to £9. 8.883 rounded. So if I was to round it there, that is round up to rounding up. That's where I'm showing my reasoning. So it's going to be £9. Okay, on to question 14. And we have simplify fully 3 times 2x plus 5 minus 4 times x minus 3. And it's an expression, this one, because it doesn't have an equals, so it is an expression. But in order to simplify it first, we need to get rid of the brackets. So we're going to have to multiply. We do not need that pink pen. Let's try again with a black pen. So we're going to need to multiply 3 times 2x and 3 times 5 in order to expand my bracket. So we're getting rid of my bracket. So 3 times 2x is going to give me 6x. And then I have my 3 times 5, which is going to give me 15. And I still keeping my plus in the middle because the 3 is a positive, and that's also multiplying by a positive. I then need to get rid of my second lot of brackets, and this is where we need to be a little bit careful because we have our negative numbers. So here I have minus 4 times x. So minus 4 times x is going to give me minus 4x. And then I have my minus 4 times minus 3. So a negative times a negative is going to give me a positive. So this is where it may catch you out, and hence why it would potentially be worth 3 marks. So once you've got it like this, you can then simplify. So I need to find like terms. So here I have 6x's, and here I've got negative 4x. So essentially I just have 6x minus 4x, which is like going to leave me 6 minus 4 is going to give me 2x. And then I have plus 5 plus 12. So I'm going to have 5 plus 12, which is going to give me 17. And that's that question complete. Okay, and on to part B. And what I've done is I've highlighted my like terms just to make it a bit simpler, because here I have one way I talk to my learners, is talking about is if they're actually, those letters are actually things, if we're simplifying. So I might have 5 apples and I'm in debt 3 bananas, and I add 3 apples and I add 4 bananas and I take away 6 loose something, whatever it is, and I add a banana. So keeping all those like terms. So here I have 5a plus 2a. So in total I'm left with 7a. And then I have minus 3b plus 4b. So minus 3 plus 4 is going to give me 1b, plus my additional b is going to give me 2b. So if it was bananas, I'd have 2 bananas. And here, that's already simplified. I don't have any more like numbers, so I have minus 6. So 7a plus 2b minus 6. I'm thinking about it, it's a bit, we wouldn't usually get 3 marks. It'd probably be closer to 2 marks for this. And on to part C and the last question. Simplify fully 3x times 4y all over 6. So I'm going to simplify this top part first, and you just literally need to do it step by step, and these keeping our numbers together. So here we have 3 times 4, which is 12. And here we have x times y, and I can't simplify them together. There's nothing squared or anything there, so it's just going to be x, y. And that's all over 6 still. But these are my numbers, and essentially I've got 12 over 6, which is like 12 divided by 6. 12 divided by 6 is 2, so I can get rid of that, and it will just become 2xy. Straight on to question 15, and we have, write 504 as a product of its prime factors. So here we're going to need a prime factor tree, and we're going to need knowledge of what a prime number is. So remembering that a prime number only has 2 factors, one in itself. So we're going to need to keep splitting it up. And if it's an even number, I always find to go for the smallest prime number first if you're able to. And again, using your calculator. So if I divide this 504, because I know it's an even number, because 4 is an even number, 504 divided by 2 is going to give me 252. I can then see it's still an even number, so I can divide it by 2 again, keeping it simple as I can. And it's going to be 126. I would always start to try and divide by the lowest prime numbers. So if it ends in 5 and 0 or 0, you'll know you can divide it by 5, or potentially, divide it by 5. Go for the smallest prime numbers, or try dividing it by 3, 7. Keep to your smaller prime numbers first. So I can see again it's an even number, so luckily I can divide it by 2 again. And this time I get 63. That is not an even number, so it's not divisible by 2, so it's keeping it simple. But however, I know a 3 goes into a 6 and a 3 goes into a 3, so I can divide it by 3. So I'm moving along. So 3 times 21 will give me 63, but I can divide this even more. So 3 goes into 21 and along with 7. And as 3 and 7 are prime numbers, that's as far as we can go. So sometimes when you get to a prime number, you know you need to stop that branch of the tree. So here I've managed to stop. So I have 2 times 2 times 2 times 3 times 3 times 7. And in order to write that in index form, I have 1, 2, 3 2's. So that's 2 to the power 3. Oh, it's a terrible 3. Make it look more like a 3. There you go. Times, and then I have 2 3's. So 3 times 3. 3 to the power 2. And only 1 7. So when it says in index form, I could write 2 times 2 times 2, but that is not in index form. So it's making sure that you're using indices there. So if you needed to revise that, it's revising prime factor trees, or prime factors, or just your understanding of prime numbers before the exam. Standard form is a way of writing big and small numbers in an easier way. So this number it doesn't necessarily need standard form. It's not a huge or big number, but there's two rules. So the first number must always be a number between 1 and 10. The first number has to be, so it can't be including 10. It must be a 1-digit number at the start. So the first part of the rule is that if that's between 1 and 10, 5.6 is between 1 and 10. But we know that in order to get 5.6, we'd need to move the decimal a certain amount of times, which means we're going to be multiplying that number by 10 or dividing it by 10, which would make it to a negative. So here, we have moved the decimal place 1, 2, 3, 4 times. So it's going to be 5.6 times 10 to the power of -4. If the number was bigger, it would go the other way around. If it was 5, 6 with the zeros on the other side, making it not a decimal, it would be 4. But it is a decimal, so it's going to be -4. So it's always the first part of the number is a number between 1 and 10, not including 10, and the second part of the number is the base 10 to the power of something, making the number bigger or smaller. And on to part C, and now we're working the other way round. So now they're asking us to write the following in ordinary number form. So I'm going to write my 3.2 here, and I'll be making my number bigger. And as there's a 5 here, I'll be multiplying the number by 10 5 times. That means I'll be moving my decimal 5 times. 1, 2, 3, 4, 5. My decimal will go here. I like to, once I've moved the decimal, I like to write a 0 in each of my arches. So remembering we will have to take that decimal out. That decimal has been moved. It's like jumped from there to there. So my final number will be 3, 2 with 4 zeros, which actually makes the number 320,000. So this is standard form if you did need to revise this. And part D, calculate the following. Give your answer in standard form. So it's a little bit using our index rules again here. So we're using our index rules again here, or like similar terms. So here I can just keep my numbers together and multiply my 4 times 2. So my 4 times 2 is just going to give me 8. And then I have my 10 to the power 3 times 10 to the power 4. And similarly, as we used the rule before, if we're multiplying and the base is the same, we need to add our indices. So we have 10 to the power 3 times 10 to the power 4. So it's 3 plus 4, which is going to give me 10 to the power 7. So keeping that rule. Another way, you might have multiplied it all out. It is a calculator paper as well, so you could put this into your calculator as well. And for question 16, we have an inequality, and it says write down the inequality shown on the number line. And there's two different things I'm going to show you here. So if it says, if it's a coloured in block, that means it can equal 3. But if it had have been a circular block like this, then that means it can go up to, but not equal to. So that this symbol would be, this one's going to be larger then. So if it was x here, then that means x would be bigger than, but not equal to this number here. But as in this situation, we have, and we're going to use x to show that it is. So we know that x, it doesn't matter which way it goes round, is bigger than or equal to 3. But as I said, if it was just a circular and not coloured in, then that would mean bigger than, but not equal to. So we wouldn't include our equal to line there. And it says list 3 integer values that satisfy the inequality. So anything bigger than 3 here. And I'm going to use 3 because it can equal 3 in this situation. Obviously, if it was non-coloured in, it wouldn't be able to equal 3. So I have 3, and I can use 4 and 5, but I'm going to use 3, 6 and 9. It's just any of those numbers, but it's just any number, a whole number. Remember, integer just means a whole number. 3, 6, 9. It could be 3, 4, 5. It could be 3, 7. Anything bigger. It could even equal 1,000,000 because it's anything bigger or equal to 3. So on to question 17, and obviously this is a predicted paper based on what topics may come up. Thinking about it, another one that could come up could be surface area or volume when it comes to these types of things. But so surface area would be if I calculated the area of each 2D face on my 3D shape. So I would calculate this area here with my dimensions given there, this area here with my dimensions given there, and this area here. So my 50 times 20, given my dimensions there. And making sure you remember that there's also the similar face at the back, also a similar face here. I don't want to confuse you too much with that, but remember volume is different to surface area. So to calculate the volume of the box in centimetres cubed, so we're trying to see how many cubes would fit into here. So first things first, I'm going to calculate the area of this front face and then multiply it by how far it goes back. So with any prism you need to find, so if I cut this here, here or here, it would look the same all the way across. So I just need to calculate the area of the face and multiply it by how far it goes back. And that would work with any prism. But for this one, I just need to do my 20, again, using a calculator, 20 times 30 times 50, and that's going to get me 30,000. Making sure I'm keeping my centimetres cubed. And essentially that's seeing how many cubes will fit in there, because in a 3D space, we're measuring how many cubes. That's why it's centimetres cubed. So we're seeing how many cubes would fit into here. And part B works slightly different, and it says the box is used to store small cubes. Each small cube has a volume of 125 centimetres cubed. Work out the maximum number of small cubes that can fit inside the box. So for this question, we're seeing how many small cubes, remembering that all the dimensions are the same for a cube. Yeah, so for a cube, all the dimensions are the same. And here, I know that 5 times 5 times 5 is going to give me 125. So this cube here is 125 centimetres cubed. So looking across here with my 5 centimetres, I can fit 10 lots of 5 going across here. So 10 cubes are going to be able to go along here. So 10 going on here. So I'm going to write 10 going across here. And this goes back 20 centimetres. So that would be 5, 10, 15, 20. So 4 cubes could fit along here. So on my bottom row, I will be able to fit 10 rows of 4. 10 rows of 4, which is going to fit 40 of these cubes along the bottom. However, how high can that row of cubes go? So here, going upwards, I have 5, 10, 15, 20, 25, 30. So 6 lots can go up here. So you've got 5, 10, 15, 20, 25, 30. So 5 lots of these cubes, 6 lots of these cubes can go up here. So 40, row of 40 at the bottom of my box, and that's going to go up 6 times. So visually, I like to show you visually. You could do a lot more working out here, but it's going to be 10 blocks times 4 blocks times 6 blocks 10 times 4 is 40, times 6 is going to be 240 cubes. The box is only filled to 80% of its capacity. Work out the actual volume used in centimetres cubed. So 80%, the couple of different ways. You can literally just put 80% of into your calculator. If you have a Casio calculator, you can put 80% of and do that 30,000, which is going to give you 24,000. Not having a Casio or just having a standard calculator, you can put 0.80 because that is the same as a decimal. 80% is the same as 0.80, and again using your times 30,000, which is going to give you 24,000 centimetres cubed. So this paper is designed to get you used to using a lot of percentages. You will get some percentages on the calculator paper. Question 18. The ratio of Ben's age to Anna's age is 3 to 5. In 4 years' time, the sum of their ages will be 40. So to find their current ages. I'm going to try and do this slightly visual because I do like to do ratio visually. And we're still trying to find out how much is in each part. The problem is we've got this additional number added on. And we don't know how much is in each part, but we do know there's equal parts. And we do know in 4 years' time, the sum of their ages will be 40. So essentially, if I was to add 4 and add 4 to this side, then the sum of all of this will be equal to 40. But if I took this 4 away and just got rid of that and took this 4 away, then I'm minusing 4 of the sum and minusing 4 of the sum again. So I know that these boxes, all of these boxes added together, I'm sorry, that's a bit of a dodgy drawing there, but I know that all of these are going to add equal 40 minus 4, which equals 32. So the sum of their ages before that must have been equal to 32. And how many boxes do I have? So I have 1, 2, 3, 4, 5, 6, 7, 8. So the sum of their ages before the additional 4 years would have been 32 divided by 8. Which is 4. So 32 divided by 8, which is equal to 4. So their current ages was 4, 8, 12. So Ben must have been 12 and Anna must have been 4, 8, 12, 16, 20. So the sum of their ages would have been 32 before. So that means Ben is 12 and Anna is 20. You could have also done this algebraically. I'm not going to do the whole question algebraically. However, if we're trying to find an unknown, and we obviously know that the unknown is the same, like it was here. So another way you could have potentially done it is done your 3x, because it's 3 times something, plus 4, plus my 5x, plus 4, equals 40, and then simplified and solved. So that would be given 8x plus 8 equals 40, and then working our way backwards. That is another way, depending on how you see it, but visually I think this is the best way I can show you. So you've got the 3 parts of the ratio add 4, and the 5 parts of the ratio add 4 is going to equal 40. So taking them off, my whole ratio, my 3 to 5, must have been equal to 32. And then it's just, once you've understood that part, it would just be a sharing ratio problem. On to question 19. A metal block has a mass of 240 grams and a volume of 30 centimetres cubed. Calculate the density of the metal block. So for this question, similarly, if you use the distance times speed triangle, you will need the formula for mass, density and volume. Always just remembering it's the mass that goes on the top of my triangle, and then I have density and volume. So essentially it's mass divided by, if I was to cover that up, mass divided by density equals volume, mass divided by volume equals density, and density times volume equals mass. But we've been given a mass, so we've been given a mass and we've been given a volume, and it's asked us to calculate the density. So all I need to do is do my 240, and this, on a calculated paper, this may come up a lot more trickier than this, but just so we can get used to using the mass, density, volume, and a little bit more practice of using it. So if you see a question, it has mass, volume or density in, you are going to have to use these formulas. So I've got 240 divided by my volume, which is 30. I'm going to make it a lot easier for myself and do 20, make it a lot easier and do my 240 divided by my 24 divided by 3 by knocking my zeros off, and I'm going to get 8. So my density is 8. Again, if this did come up on a calculator paper, it is likely to come up a lot trickier than this. It can do. And if it does, remember, just try and mop those marks up by just plugging some numbers into that formula. So even if it is a trickier problem question with more problem solving, by just plugging mass or density or anything into your formula, you'll be able to get some marks. Mop up them marks. Also, don't forget to add your units in for this one. So this is 8 grams per centimetre cubed. Question 20. A quadrilateral ABCD is drawn. Side AB is extended to the point E. The exterior angle at B, so here, EBD, is labelled Y. The 4 interior angles of the quadrilateral are 2x, x plus 5, 55, and 2x minus 25. Find the value of Y. You must show all your working and give reasons for your answer. I can't quite do this angle here. It would be nice and easy if these lines were parallel, because then it would just be 55 using angles in alternate angles. However, that's not the case here. So I need to work out these angles. If I can work out this angle here, I can work out the angles on a straight line and calculate Y. So I hope you know, if you didn't know, you now do, that angles in a quadrilateral add up to 360. So angles in a quadrilateral add up to 360. It has said reasons for your answer, so quadrilateral, some kind of rule there. Make sure you write angles in a quadrilateral add up to 360. So I need to add these angles up to make sure they add up to 360, and then I can calculate my value of x. So I could write it all out, x plus 5 plus 2x plus 55 plus 2x minus 25. However, I'm just going to make it a little bit more simpler for you and for myself, and just add all my x's up first. So all my x's here, I have x, add 2x is 3x, plus 2x is going to give me 5x. So I have 5 x's. I then have plus 5 plus 55, which is going to give me 60, and then 60 minus 25, which is going to give me 35. So I've managed to create an equation based on what I know. So I know that the angles equal 360. I also know that, so all of these angles added together equals 360. That will help me be able to find x and therefore be able to work out this angle here. If you do need practice on solving equations, please go back and practice. There's lots of different ways to solve equations. However, I'm going to stick to this method, the balancing method for each side. So here I have plus 35. So I want to get rid of that I want to get rid of that 35. So I'm going to subtract it and take it away, just so I can be left with my 5x. So I've got my 5x still. However, this is gone now. However, if I take 35 from one side, I need to subtract it from my other side as well. So that is going to give me a 360 minus 35. Make sure you're just using a calculator if you need to. So that gives me 5x equals 325. Because that's 5 times x, if I divide by 5, I'll get my x on its own. So again, reversing. When we're solving equations, we do the opposite. In maths, every action has an opposite action that will get us back to where we were. So 5x divided by 5 will just give me my x on its own. And then I have 325 divided by 5, and again, using a calculator, will give me 65. So 6-mark question, I've potentially got 1, 2 or 3 marks here. And I still need to work out what my angle here is, one angle at B. So I have 2 times 65. So now by substituting my 65 into my expression, I'll have 2 times 65, because that's my 2x, minus 25. So my 2 times 65 is going to give me 130, minus my 25 will give me 105. That means my angle here equals 105. Angles on a straight line, angles on a line equal 180. So therefore, if I do 180 minus my 105, it's going to give me 75. So y equals 75. You will always get some kind of question where you have to form an equation and expressions from shapes in order to solve something. So as long as you're able to discover whatever rule it is, sometimes it might be the perimeter of the shape and you'll have to add the sides. Lots of different ways where you'll have to form an equation and solve it. So forming expressions and equations, if you did need to revise that topic. On to question 21, and we have 3/4 divided by 2/5. And a lot of you will use KFC method to divide fractions. So we're asking ourselves the question, how many 2/5 are going to 3/4? So we keep the first fraction the same. So keep, flip, change. So a quick little revision on this. Keep, flip, change. KFC. So we keep the first fraction the same, 3/4. We flip the second fraction, so we want the reciprocal, but we don't need that word, we just need to know that we flip it. 5/2. And we change the sign. So we change the sign from divide to times, which makes it so much easier for us to do, because multiplying fractions is actually much easier than subtracting or adding fractions. So all we need to do now is 3 times 5, which equals 15. So we only need to multiply the tops and multiply by the bottom. And we have 15/8. 15/8. And it does say simplest form, which usually means give your answer as a mixed number. So every time I have 8, so if we thought of it as a pizza, excuse my messy pizza, if you thought of it as a pizza, every time I have 8 slices, if it was cut into 8, every time I have 8 slices, I have 1 hole. So here I have one whole pizza, but then I have 9, 10, 11, 12, 13, 14, 15 left over. So that's 7 left over if I'm to count up to 15. So I have 7 eighths, 1 and 7 eighths. A cafe makes a large chocolate cake for the day. In the morning, customers eat 3/5 of the cake. In the afternoon, another 1/4 of the cake is sold. What fraction of the cake has been eaten altogether? And here we are going to need to add our fractions. So here we will need to add our fractions. So we have 3/5 add 1/4 because we need to know how much of the cake was eaten. We cannot add or subtract fractions unless the denominators are the same. So you can't add eighths and quarters, or you can't add thirds and sixths, 8 thirds and quarters. But you can add like 2/4 and add a quarter is going to be 3/4. So as long as the denominator is the same, it makes it's able to add them. So here I know that 5 goes into 20 and 4 also goes into 20. So I'm going to actually move it down here. Leave that. I'm going to move it down here. So I'm going to make my denominators 20. But what did I times my 4 by? My 5 by, I times it by 4. So I also need to multiply this by 4 because whatever I do to the top, I must do to the bottom. And what did I multiply my 4 by? I multiplied it by 5, so I multiplied my top by 5, which is going to give me 17 over 20. So as soon as the denominator is the same, I am able to add them. Okay, and the last part of this question is what fraction of the cake is left at the end of the day? So if the cake was a whole cake, this plus something is going to equal a whole number. So a whole number would be my full 20 over 20. That's going to be my whole cake, 20 slices out of the full 20 slices. So what do I add to 17 to get my 20? Must be 3/20. So at the end of the day, 3/20 of the cake is left. Now I'm looking at that, I quite fancy some chocolate cake. Question 22. The table shows some of the values of y equals minus 2x plus 3 for the values minus 2 all the way up to 2. Complete the table. So we have when x equals minus 2, we need to plug it in, to substitute it into our equation. So we're going to keep swapping our number in. So our equation is minus 2x plus 3. So substituting each of those values in, we have minus 2 times minus 2 plus 3. So we have minus 2 times minus 2 is going to be 4 plus 3 equals 7. So negative times a negative, keeping an eye on that. And then for this value here, we have substituting 0 in. Anything times 0 is going to equal 0. So I have for my next one, y equals 0 plus 3, which is just going to give me 3. And again, we have y equals 1. Y equals minus 2 times 1. So I will write this one out. Again, we're substituting it in, similarly to how we did on paper 1. So it's the substitution we're practicing here. Y equals minus 2 times 1 plus 3. So you've got minus 2 times 1 is going to give me minus 2, plus 3 is going to equal 1. You might have noticed a pattern again, it's going down in 2s each time. So, but we will just for practice substitute the next value in. So we have minus 2 times 2 this time. So this time we're substituting our 2 in, plus 3. Minus 2 times 2, negative times a positive, is going to give me a negative. plus my 3, so negative 4 plus 3 is going to equal negative 1. We then have all of our values here, so we have x and y for each of our values, so we've got some coordinates here, so I have -2 and 7, -1 and 5, 0 and 3, 1, 1, and 2 minus 1. Oh, complete that with the bracket. Okay, next we have part B, and we just need to plot our points. And I want to give some extra tips on this graph as well. I know there's a similar question on the predicted paper, part 1 of drawing the graph. So I probably should have done a quadratic one, so I'm going to give you some tips on that. So plotting the points for a linear graph where we only have one x here, so 1 to the power of 1. So I go along the corridor and up the stairs, -2 to 7, and I can plot a point there. And essentially I could probably get away with just plotting 2 points. So if I go 2 and -1 here, I could get away with plotting 2 points and drawing my straight line, but just to show you for visual purposes, we have -1 and 5. I will plot all the points 0, 3, and 1, 1. Then I need to grab my ruler and make sure I draw my line all the way going down. Once you have positioned your ruler, make sure your line goes all the way down because your graph will continue for the whole line. So once you have your ruler, make sure you continue that line all the way down. And that's our graph drawn all the way down. What I did want to expand on is if you did have some type of graph where y was equal to x squared or something raised to the power of x squared, it could be anything, but that's basically looking like a quadratic. I'm just going to make it look like this. You would still need to substitute the values in exactly how you did before. So exactly how if it was 1, you would do 1 times 1 plus 3 times 1. You still substituting those values in. However, your graph points would look more like this. So your graph would look more like this type of shape. So don't be so this is a straight line graph, whereas if you have it raised to the power of 2, it will look more like this. And just to expand that those waves go more and more depending on how much the power is. So it's only going to look like a straight line if there's only one x and not any x squared or anything like that. Okay, and on to question 23, and we have some reverse percentages. So I'm going to write the topic name here, reverse percentages. I've put this in because I see so many people make mistakes on this. If this comes up, if a percentage one like this comes up at the end and you think you're just calculating 25% of that total amount, you're usually going to have to do reverse percentages. If you think it's a bit too easy at the end of the paper, then it usually is. So a theme park is running a special promotion. Visitors who book online receive 25% discount on the original ticket price. However, there is also a £3 booking fee added after their discount is applied. Alex books a ticket online and pays £48 in total. Work out the original price of the ticket. So first things first, he had the £3 taken off. So before we do anything with our percentages, he had that original £3 added on, the £3 booking fee. So it would have been £45 because it's the 25% was after the discount. So we've got £45 and we don't want to work out 25% of that £45 because that's not the original value. We need to know what the original value is. That's what we're trying to get. So it was 25% of the original value. So if the original value is 100%, and then 25% was taken off it, that means 75% was paid. So 75% was paid. So this £45 was only actually 75% of the value. So in multiple different ways we can do this, and this reverse percentages always reminds me of a proportion problem, or a problem to do with recipes where you go back to 1 and then back to whatever we need to go to. So in this case, I'm going to go back to 25% because I want to get to 100%. So if I divide this by 3, I could also divide it by 75 to get 1%, but I'm going to divide it by 3 to get 25%. So if I divide it by 3 and get 25%, I'll do it on both sides. I have £45 would have been equal to 15. But I want my original value. So I actually want my original value, which means I want my 100%. So if I times my 25% by 4, I'm going to get my original value, and I'm going to get £60. So my original value is £60. Another way you might have done this problem is going back to 1%. So it's probably more likely on a calculator paper to be a decimal, to make it a bit more tricky. So another way I might have done this is gone all the way back to 1%. So imagine, I'm still 100% minus 25% equals 75%. To get back to 1%, I would need to divide by 75. And again, using your calculator to make it a lot easier, if I divide that side, if I'm dividing to my 75% by 75, I also need to divide this by 75. So if I do my 45 divided by 75 on my calculator, that's going to get me £0.60, or 0.6 on my calculator, and then multiplying by my 100. Because you are likely to get one that's not as simple on a calculator paper, but just to help you understand the process more than anything. So again, 1%, in order to get from 1%, I would need to multiply it by 100, which is going to give me my original value, which is £60. Okay, and on to question 24. If you find, and this could be in some kind of problem solving way, lots of different ways that this might come up. If you come across a question and you have an unknown length, but you can see that you can make a right angle triangle towards the end, and sometimes these questions come up like a double triangle with this in the middle, and you can see that that's a right angle triangle. If you can see that you can form some type of right angle triangle and you need to find a side, we will usually need to use Pythagoras. I don't like to just use a squared plus b squared equals c squared. I like to visually teach Pythagoras. However, for the purpose of this paper, we will just be going through the motions. Okay, so we have calculate the length of AB. So we need to calculate this length, and we've given 2 other lengths. So because we've got our longest length, then we're using a squared plus b squared equals c squared. Because we have our longer length, our c squared, we will need to subtract in order to get backwards to the one we need. So I'm going to put into my calculator 16 squared minus 12 squared. So 16 squared minus 12 squared, which is going to give me 112. But that means that's going to be my a squared. So it's still squared. It's still not got the full length A lot of people might leave their answer there. We need to make sure we're using our square root button. So I'm going to square root my 112 as shown above. Remembering to use your standard to decimal button if we need to, and that's going to give me 10.5830000524. We don't need that many decimal places, so I'm just going to round it to 2 decimal places. So the actual number is 583000524, but we don't need that many. The question probably should say round to 2 decimal places or 1 decimal place. So as 3 is less than 5, I can leave it the same, and it's going to be 10.58 centimetres. Don't forget our units. That's centimetres and that's centimetres. So this one will also be centimetres. Okay, and now on part B, we've been asked to find the angle at C. So an angle in a right angled triangle, we will need to use trigonometry. And I think without having a practice of this question, if it's very, very new to you, you would probably need to go back and have some revision of it. I'm sure you've had lots of different ways taught to you, because obviously everyone's different and you've all had different learning. I'm going to use the triangle method, and we're using good old SOHCAHTOA. So if there's an angle involved and we need to find a side length or an angle, so originally we were given 2 side lengths, so we can use, and we needed a side length, so we could use Pythagoras. However, if there's an angle involved and only one side, or that we need to find the angle, we will need to use SOHCAHTOA, and I write it in that way, just so SOHCAHTOA. So we need to be able to label our sides. So we've got our angle here. So our angle here, I always see my angle look like an eye, and that would be looking at my opposite side. So my angle is looking at my opposite side. So we need to label our sides. Our longest side's always going to be called our hypotenuse. I'm not going to write the whole thing out. Okay, we'll write the whole thing out. And then adjacent means next to. Adjacent is next to, so this is my adjacent side. So that's where we get our O, our H, and our A from. And I like to ask myself 2 questions when I'm going through this. What do I know and what do I want to know? And here we know, what do we know? We know our H and our A. So we need to have a look, and we want to know the angle. So we have a look in here. This is the only triangle that has an A and a H in. So just identifying the one that you need to use will usually give you a mark. So then you need to cover up the one you want to know. If I was trying to find a side length, again, I do think practice of this, if you need it, go back and have some practice of this and then come back to this question. So I'm going to be using cos, and I need to find my angle. So I need my inverse button. So showing you on the calculator to the side, you have your cos, but as I've said before, in maths, there's always a reverse. So we need the inverse. If we need to find the angle, we will need the inverse button. And remember, a calculator is like a computer, so you will need to find your shift button to get the cos -1 as shown to the side. Okay, so, and as we have A over H, so A is above H, so this is my adjacent here, so we need the 12 to go on top of my fraction, and my H, my 16, to go underneath. And that's going to give me the answer 41.409, 6222, 62211. However, we're not going to leave our answer like that. We're going to keep it a bit tidier, and as we rounded to 2 decimals above, we're going to round to 2 decimals here. and I have 41.409. But because 9, we go around 2 decimal places, and because 9 is above 5, we will round up to get 41.41. Because it's an angle, we'll need to show it is degrees. Okay, and now on to question 26, and we've got vectors, adding and subtracting vectors. I like if this question comes up on at the end, but only if you know how. So usually with my learners, I'll maybe do a couple of coots to try and help them remember this one, because it's easy when you know how, because it is simple addition and subtraction, and it's a good way to mop up some marks. So I have 3 lots of A, and I'm given that A is 3, 2. So I'm going to calculate my 3A first. And if I'm scaling, I just multiply everything from my vector by 3. So 3 times 3 is going to be 9, and 3 times 2 is going to be 6. Just a quick side note, all a vector is describing how far right or left something goes, and that could be anything, could be a shape, could be a dot. It's just explain how far right or left it goes. So this one goes 3 to the right, and how far up or down it goes. So currently A is going 3 to the right and 2 up, and B is going 1 to the left and 4 up. So if it's negative, it means left or down. So I've calculated 3A, so I'm going to put this here, 9 and 6. So this is my 3A. 3A equals, so that's my 3A. Do that right there. Okay, and then we're just subtracting B, and we haven't done anything with B, so we're keeping B as it stands, minus 1, 4. And just where we need to be careful, where we may lose marks, is when we have a negative in these cases. So I have 9 minus negative 1. And because it's 2 negatives, I'm going to need to add 1. Minus would mean I'm adding 1. So 9 add 1 is going to be 10. And then I have 6 minus 4, which is going to be 2. So the only thing to keep an eye out with these, with vectors, right, vectors there, adding and subtracting vectors, it can be quick marks if this comes up, quick, nice, easy marks if this comes up. So maybe have a quick revise of it, or do some quick couple of questions, because if you've got this far, then you can do 9 add 1, and you can do 6 minus 4. You just need to remember that the rules for it. So the final answer is 10, 2. Question 26. A large water tank is filled using identical pipes. When 3 pipes are used, the tank fills in 12 minutes. The manager wants the tank filled in 9 minutes. I mean, a little bit petty for the manager, but there we go. How many pipes are needed in order to do it in 9 minutes? So let's start by writing that 3 pipes is going to take 12 minutes, or 12 mins. 12 mins. Okay, so let's just see, how long is it going to take 1 pipe? So how long will it take 1 pipe? Well, if 3 pipes takes 12 minutes, 1 pipe is obviously going to take 3 times the amount of time. So it's going to take 3 times the amount of time. So 1 pipe, 3 is going to be doing triple the amount of work. So it's going to take 1 pipe 36 minutes. But I want to get this down to 9 minutes. So I want to get it down to 9 minutes. So I need it quicker than the 3 pipes. So because I'm going to divide this side by 4, 36, 9, 18, 27, 36. So if I'm dividing this side by 4, then I'm going to have to like quadruple the amount of time. So I need to quadruple the amount of pipes. So on this side, I will need to multiply by 4. So essentially, if you're dividing on one side with indirect proportion, if I'm dividing by one side, so by 3, I need to times by the same number on the other side, and vice versa. So it's going to take 4 pipes to get to the 9 minutes. So it's going to take 4 pipes. Final answer. Okay, now on to part B. And luckily, because we've already worked out, saying calculate how long it will take to fill the tank using 5 pipes. So I'm going to go back to my original question, and I know that it takes 1 pipe. So I've managed to work out that it takes 1 pipe 36 minutes. But I need 5 pipes, so I'm going to be timesing by 5. So I now have 5 pipes. But remember what we were doing before. If I times by the one side, I'm going to need to divide by the other side. So on the other side, I will need to divide by 5. And putting that into my calculator to get my 36 divided by 5. So into my calculator, my 36 divided by 5 is going to give me 7.2. 7.2 mins. And expanding it a little bit here, if I was to do it in minutes and seconds, so that would be 7 minutes. But decimal time again, we have that decimal time again. I've got 0.2 of 60, because there's 60 seconds in a minute. So 0.2 of 60, and you can put that straight into your calculator, is going to give me 0.24, or 24, I mean, 24. So it's going to take me 7 minutes and 24 seconds. Well, not me, it's going to take 5 pipes. And on to the very last question. We've finally done it. And we have, for this question, we have some simultaneous equations. And these could come up as a graph or as equations. So 2 different ways simultaneous equations could come up. So a cafe sells sandwiches and salads. A sandwich costs £4, important bit of information, and a salad costs £6, important bit of information. One lunchtime, the cafe sells 18 items altogether and takes £88 in total. Let S be the number of sandwiches sold and T be the number of salads sold. So we know that we don't know how many there is, but we know that the number of salads, the number of sandwiches, and the number of salads total 18 items in total. So we've written an equation to represent this. And we know that 4 lots of that amount, so 4 lots of £4 times the number of sandwiches, add £6 times the number of salads, is going to equal £88. So we've managed to write two equations and hopefully got 2 marks. Solve the simultaneous equations to find out how many sandwiches and how many salads were sold. So we've got our 2 equations, and with simultaneous equations, you can't, so at the moment we have 2 unknowns. So we've got S as an unknown and T as an unknown. And we can't, unless we have one unknown, we can't solve the equation. So currently we have 4S, and I'm going to put the most amount on the top, plus 6T is equal to 88. And one way I can solve this is by subtracting one equation from the other. But if I did 4S minus S, I'm still going to be left with 3S. And 6T minus T, I'm still going to be left with 5T. But what I can do is change my equation. So if I multiply this equation here by 4, so I'm going to do that over here. S plus T equals 18. And if I multiply all of this by 4, to give me 4S plus 4T, and then using my calculator, because I don't need to work that out myself, and that's going to be times 18 by 4 is going to give me 72. I now have the coefficient the same for s. So I have 4s plus 4t equals 72. And I can subtract one equation. Oh, I don't need to put that on here. One equation from the other. So I have 4s minus 4s. No s is left. 6t minus 4t is going to give me 2t. And then I have 88 minus 72, which is going to give me 16. That means 2 lots of something equals 16. So divide 16 by 2, and I'm going to get t equals 8. So that means 8 salads were sold. 8 salads were sold, and I've managed to get a few of my marks here. And moving on to the next question. So t equals 8. Moving on to my next part of the question, I can now substitute this into this equation here. So substituting my number of salads, so that means s plus 8. So the number of sandwiches plus 8 equals 18. So 10 plus 8 equals 18. Therefore, s must be equal to 10. So 8 salads and 10 sandwiches. 10 sandwiches. But that is quite a tricky question, but you would expect a tricky question to come up right at the end. We'd expect it to come up at the end, but we need to revise simultaneous equations. If you did want to push for that grade 5, if you really do want to push for that grade 5, I would recommend revising simultaneous equations. And that is the end of the second predicted paper. Hopefully you've already found predicted paper 1, or been given it to your teacher from your teacher with the QR code. I might aim to get some more past papers. Unfortunately, I've not got the time now to make any more predicted papers. But if I think of anything that is a common topic that might come up, I might make short videos. And also, I may find the time